Before we start, just briefly about me, I'm currently a product lead at Google, and my role is to build ML platform and tools for all internal Googlers. So you can think of Gmail, YouTube, Waymo. So all of these teams are building and shipping models to production. So we build a common set of platforms and tools for these teams. And prior to Google, I was at Meta working on AI platform there. So they have FB Learner Flow, which is their internal platform on which they run all their AI workloads. And before that, at Databricks and Netflix, primarily in the capacity of building big data and AI platforms. And that's my bread and butter as well. Today, I'll be covering Gemini and Gemma models that were released recently, just giving an overview of all the recent series of models that were released, and then an overview of AI landscape at Google, and also the Gemini adaptation workflows that we see when users are trying to adapt Gemini for their own product-specific use cases, and common characteristics and challenges that we see. I just wanted to give a heads up. It's a more of a MLOps lens, which will touch on the different life cycle, Gen AI life cycle. I'm not going to go into research on any specific aspect. So with that, yeah. So for Gemini, we launched Gemini 1.0 end of last year. So the key goal for having Gemini 1.0 was we want to build a more natively multimodal model. And the reason is, like, if we want to get towards first AGI, we want to have a model that can understand text, audio and video simultaneously. So that's the goal for Gemini 1.0. We released it in 3 flavors, Ultra, Nano, and Pro. Nano for the on-device, and Ultra with all the best-in-class across different modalities. And in February of this year, we released Gemini 1.5. The goal for 1.5 was we wanted to push the context a window that was possible. So we released it with a 1 million token capacity, so which is 1 hour of video, 10 to 11 hours of audio, or like 700,000 words. Like you can send in large PDFs as one input to the model and get responses back. So that was the goal, to push the context window as much as possible with Gemini 1.5. Following that, in May, in Google I/O, we announced 2 major things. One is Gemini 1.5 Flash, which is a much faster and smaller model. So it's faster in the sense that you can get in sub-second latency results for the first tokens from the model. And it is also has a good quality to cost ratio. So if you're not looking for very high quality output, but you're willing to compromise on quality and get at a fraction of a cost, so Gemini 1.5 Flash could be a good fit for that. And then we also expanded Gemini 1.5 Pro to 2 million context, so more text and more video and audio to the model. Along with that, we also started releasing an open series of models called Gemma. Primary goal is to advance research and work with the community. The first series was like Gemma 1.0, which was released in February. It came in 2 different sizes, 2 billion size model, and that was primarily for CPU-based inference and on-device. And then there is also a 7 billion parameter model, which is the most common one. And along with it, there is also a few series of variants for Gemma, like Code Gemma for all the code generation and the math-related stuff. And there is also Recurrent Gemma, which is a different model architecture, and Pali Gemma, which is a more vision-based model. So all of them are in the open source series. And then last month, we released Gemma 2.0. So Gemma 2.0 is the largest from Google so far. It's 27 billion parameters. And it's also one of the best open source models there so far. I know every month there is new models coming in. So this is like the overall chat arena, and you can see Gemma 2 is one of the best there. And it's also nice to see open source models catching up with the closed source. So that is also trending nice. So coming to Google, so our goal is to not just make these foundation models available through Google Cloud or through open source. We also want to make sure that different products in Google can adapt the Gemini models, like Photos or Gmail or search. All of them can adapt the Gen AI related use cases into their product experience, like YouTube creator economy, for example, or like Photos can deliver more intelligent results. So there are hundreds of teams that work on adapting these Gemini foundation models for their product use cases. And for the rest of the talk, I'm going to give an overview about what those development lifecycle looks like and what are some of the challenges that we see. So the standard ML workflows at Google, and this is pretty much the industry standard as well, like where you have product experiences, users, user actions like views, clicks. It generates raw logs, and then we create sessionized logs, features, and then training, and then deploying models. This has been the case. With Gen AI, that is kind of changing. Now we see a two-step process where we have Gemini, GDM, or like Google DeepMind, and the research teams building foundation models. So they do a series of steps in terms of like compliance filtering, mixture tuning, and running foundation model evaluations, and then shipping the foundation model. And then we have different product teams within Google who are looking to adapt those foundation models. And the typical workflow there is like start with prompt engineering. And if that's good, it goes to production. If that's not enough, like then users start to take their product specific data or the human preferences they got from their specific products and start building SFT or RL reinforcement learning based tuning, and then run either human in the loop or auto evals, and then finally optimize and push it to production. So this has been like an emerging workflow that we see across different teams. If we double click a little bit and see how that workflow looks like, there are 4 to 5 stages. The first one is around all the tuning that we did once. And then we have what we call like model validation, so which is primarily around making sure that you choose the best checkpoint, you quantize the model, make it ready for inference. And then even in inference, we see a couple of different patterns. One is around interactive inference, where there are like I call eyeballing user journeys, where folks are trying to do side-by-side comparison and looking at their results. And then there are use cases where like folks have 1 million rows of data sets and they just want to run a batch inference, which is more for throughput optimized system. And then the next phase is around like rating and scoring. If human rating is needed, data set gets enqueued to a labeling platform, and then we dequeue the results. Or there is also LLM as judge or auto eval workflows where people build their own auto rater models and try to do the scoring and then do a summarization or analysis of the results. And then finally, there is a release candidate that gets generated. And after that, there are more approval related process, compliance, and other things. I won't go into that. So, but this is just the key steps in adapting a Gemini model. So what are some of the workflows that we see, right? So the first one is the training tuning related workflows. The second bucket is around the deployment related workflows, like making sure that the model is ready. The third one is the evaluation related workflows, more around the human eval and auto eval. And the last one is distillation related workflows. So distillation is more where you have a fine-tuned checkpoint and you have a large corpus of unlabeled data. So you can run a bulk inference and create a new silver labeled data sets, and then do a student model training from that, and run evaluation. So that provides great benefits, like especially if you're doing on device or similar use cases where you want a smaller model. Distillation can save you a lot of cost as well. So coming to the last piece, what are the characteristics and challenges that we see? The first one is heterogeneous training phases. So previously there used to be one training loop. It was pretty straightforward. Now we have SFT, RLHF, and LoRa, which means we also see specialized training tuning frameworks and services to leverage TPUs and GPUs efficiently. The second one is around JAX. So we use JAX heavily for all the model training. JAX is efficient, but efficiency is good. We need that at that scale. Like even small amount of efficiency translates to large amount, like millions of dollars in cost savings. But we need also more JAX-based tooling. So that is another opportunity and challenge. The third one is around, there are many human touch points in the human rating workflows that we see. So this is when you enqueue the results to labeling platforms like Scale or whatever you're using. Sometimes we see like causing delays in end-to-end latency. So trying to shorten that latency, and also developer toil in trying to automate. So these are some challenges. The fourth one is around having different types of eval and eval criteria. So we have to evaluate the model for creativity or factuality or safety, persona. So all of that requires more sophisticated eval tools. And of course, there are plenty of talks covering here about some of the details around these eval tools. And the fifth one is around model scraping. So which is more around I would say, during the experimentation phase, we see there are a lot of different types of inference patterns, like the interactive and batch ones. So they have different spectrums in the efficiency frontier of cost versus responsiveness. For interactive, folks want fast response. They are okay with few idleness in GPUs. For batch, they want more throughput optimized. And it may not be responsive. So we have to kind of build systems for those kind of scenarios. And also model deployments and serving is also complex. Because in cases where if you're doing LoRa tuning, you're not really, there is no model. You have an adapter set of weights, but you can patch them onto the base model. You can also create new fully supervised fine tuning, in which case you're creating a new set of models. The large context windows all makes that model deployment and serving complex as well. And the last piece is the application development patterns, like around RAG and agentic workflows have very different tooling needs and user journeys as well. And it's very nascent, how that's going to pan out is still, there is a lot of innovation happening. So these are some of the challenges and the opportunities that we see internally. And if you are considering around, say, picking up open source models and building your adaptation workflows, these are some things to keep in mind as you embark on that journey. So I think that's my end.